In this video, we will study how to derive formulae for finding Laplace transforms of some standard functions. The list of these standard functions and their corresponding Laplace transforms have been given in this table, and now we will see one by one how to derive formulae for finding Laplace transforms of these standard functions. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. We will see how to find Laplace transform of hyperbolic sine at and cos at. But before that, let us find Laplace transform of e raised to at, which will be integral from 0 to infinity e raised to minus st into e raised to at, that will be integral from 0 to infinity of e raised to minus s minus a t dt, which is e raised to minus s minus at upon minus s minus a from 0 to infinity, which is minus 1 upon s minus a into e raised to minus infinity minus e raised to 0, which is minus 1 upon s minus a into 0 minus 1. So Laplace transform of e raised to at equals 1 upon s minus a. We will use this Laplace transform of e raised to at to be 1 upon s minus a to find Laplace transform of sin h at and cos h at. Replacing a by minus a, in this formula we get Laplace transform of e raised to minus at equals 1 upon s minus a, which will be 1 upon s plus a. So Laplace transform of e raised to minus at is 1 upon s plus a. We have hyperbolic sine at equals e raised to at minus e raised to minus at upon 2. So Laplace transform of sin h at will be Laplace transform of, which will be half Laplace transform of e raised to at minus Laplace transform of e raised to minus at, half times 1 upon s minus a minus 1 upon s plus a, half times s plus a minus s plus a upon s minus a into s plus a will be s square minus a square. S minus s is 0, so we get half times 2a upon s square minus a square. Cancelling 2, we get Laplace transform of sin h at equals a upon s square minus a square, where s should be greater than a. We have hyperbolic cos h at equals e raised to at plus e raised to minus at upon 2. So Laplace transform of cos h at will be half times Laplace transform of e raised to at plus Laplace transform of e raised to minus at, which is half into 1 upon s minus a plus 1 upon s plus a, half times s plus a plus s minus a upon s minus a into s plus a will be s square minus a square, which is half into a minus a will be 0 into 2s upon s square minus a square. So we get Laplace transform of cos h at to be cancelling 2 s upon s square minus a square, where s is greater than a. In order to find Laplace transform of sin at and cos at, we will consider exponential form I at of a complex number in the polar form as cos 80 plus I sin 80. Now Laplace transform of cos 80 plus I sin 80 will be Laplace transform of e raised to I 80, which is 1 upon s minus ia multiplying by conjugates 1 upon s minus ia into s plus ia upon s plus ia will be s plus ia upon product of s minus ia and s plus ia will be s square minus I square e square, which is s plus ia upon s square plus a square. The same can be written as s upon s square plus a square plus I times a upon s square plus a square. On the left hand side, we write Laplace transform of cos 80 plus I times Laplace transform of sin 80. Equating real parts, we get Laplace transform of cos 80 as s upon s square plus a square, and equating imaginary parts, we get Laplace transform of sin 80 as a upon s square plus a square. We will see how to find Laplace transform of c raised to 80. But before that, let us express c raised to 80 in terms of exponential power of e. We assume x to be c raised to 80. Taking logs on both sides, log x to the base e will be log c raised to 80 to the base e, which is 80 log c to the base e. Now we can write this logarithmic form in exponential form as this x equals this e raised to this 80 log c. That is, from here we can write c raised to 80 equals e raised to 80 log c. Now we have already found out Laplace transform of e raised to 80 equals 1 upon s minus a. Therefore, Laplace transform of c raised to 80 will be Laplace transform of this e raised to a log c t, which according to this result will be 1 upon s minus a log c. So we get a new result. Laplace transform of c raised to 80 equals 1 upon s minus a log c. Of course, provided c is positive and s greater than a log c. Accordingly, let us see what will be Laplace transform of 5 raised to 3t. This will be according to above formula 1 upon s minus 3 log 5, or Laplace transform of 3 raised to minus 5t will be 1 upon s minus 5 log 3, which will be 1 upon s plus 5 log 3. Laplace transform of 2t square minus 3t minus 4. This is 2. Laplace transform of t square minus 3. Laplace transform of t raised to 1 minus 4. Laplace transform of t raised to 0. This is 2 into 2 factorial upon s raised to 2 plus 1, that is s cube, minus 3 into 1 factorial upon s raised to 1 plus 1, that is s square, minus 4 into 0 factorial upon s raised to 0 plus 1 s raised to 1. It is 2 2's are 4 upon s cube, because 2 factorial is 2, minus 3 upon s square, because 1 factorial is 1, minus 4 upon s, because 0 factorial is also 1. Find Laplace transform of 2 e raised to minus 3t minus 4 e raised to 5t. This will be 2 Laplace transform of e raised to minus 3t minus 4 Laplace transform of e raised to 5t. This is 2 into 1 upon s plus 3 minus 4 into 1 upon s minus 5, 2 into s minus 5 minus 4 into s plus 3 upon s plus 3 into s minus 5, that equals minus 2s minus 22 upon s plus 3 into s minus 5. So finally the Laplace transform will be minus 2 into s plus 11 upon s plus 3 into s minus 5. Find Laplace transform of sin 3t. This will be 3 upon s square plus 3 square, 3 upon s square plus 9. S is positive. We have by addition formula sin omega t plus alpha equals sin omega t cos alpha plus cos omega t sin alpha. Therefore, Laplace transform of sin omega t plus alpha will be constant cos alpha into Laplace transform of sin omega t plus constant sin alpha into Laplace transform of cos omega t, which is cos alpha into omega upon s square plus omega square plus sin alpha s upon s square plus omega square. So this is required Laplace transform. Find Laplace transform of t raised to 3 upon 2. Here 3 upon 2 is a positive rational number. Therefore, according to above formula, this will be gamma 3 upon 2 plus 1 upon s raised to 3 upon 2 plus 1. I have explained the derivation of this result in my previous video, which will be gamma 5 upon 2 upon s raised to 5 upon 2. Now this gamma 5 upon 2 according to above rule will be 5 upon 2 minus 1 into gamma 5 upon 2 minus 1 upon s raised to 5 upon 2. This will be 3 upon 2 gamma 3 upon 2 upon s raised to 5 upon 2. This will be further equals 3 upon 2 into again 3 upon 2 minus 1 into gamma 3 upon 2 minus 1 upon s raised to 5 upon 2. This will be 3 upon 2 into 1 half into gamma 1 half upon s raised to 5 upon 2. This will be 3 upon 4 into, as given above, gamma half is square root of pi upon s raised to 5 upon 2. So this is Laplace transform of t raised to 3 upon 2. On the same lines, we can find Laplace transform of t raised to half, which will be according to above formula gamma half plus 1 upon s raised to half plus 1. This will be gamma 3 upon 2 upon s raised to 3 upon 2. Now according to above rule, we will write this gamma 3 upon 2 as 3 upon 2 minus 1 into gamma 3 upon 2 minus 1 upon s raised to 3 upon 2. This will be half into gamma half upon s raised to 3 upon 2. So which finally will be half into, as given above, gamma half is square root of pi upon s raised to 3 upon 2. So this is Laplace transform of t raised to 1 upon 2. Laplace transform of sin square at is half Laplace transform of 1 minus cos 2at, which is half into Laplace transform of 1 as given above is 1 upon s minus Laplace transform of cos 2at as given above is s upon s square plus 4a square, which is half into s square plus 4a square minus s square upon s into s square plus 4s square equals s square minus s square 0, 2 ones are 2 twos are 2a square upon s into s square plus 4a square. We cannot directly find Laplace transforms of trigonometric functions like cos cube at, cos square at, sin 5t, cos 3t, etc. because we do not know direct results of finding Laplace transforms of these trigonometric functions. So we have to convert them by algebraic or trigonometric manipulations into simple functions, of which we can find Laplace transforms. So this cos cube 80 can be written as 1 upon 4 cos 80 plus 3 cos 80, and we can easily find Laplace transform of this part easily. Similarly, we can write cos square 80 as 1 plus cos 280 upon 2, and we can easily find Laplace transform of this part. Or we can write sin 5t cos 3t by defactorization formulae as 1 half sin 5t plus 3t 8t plus sin 5t minus 3t 2t. And now we can easily find Laplace transform of this part. So basic knowledge of trigonometry and algebraic manipulations is must in finding Laplace transforms of these kinds of trigonometric functions. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.